In this example, we are going to determine whether or not the functions given to us in parts A, B, and C are solutions to this differential equation. A differential equation is simply an equation involving y and its derivatives. So here we have the second derivative and the original function y showing up in this differential equation. So let's go in and check whether or not y equal to sine x is a solution. So to do that, I'm going to need to plug in the second derivative and subtract the original function. So let's take the first derivative and the second derivative. So y is equal to sine x. The derivative of sine is cosine x. So y prime is cosine x, and the derivative of cosine is negative sine x. So y double prime is negative sine x. Now let's go plug them into our differential equation and see if they satisfy it. So for y double prime, I'm going to substitute in negative sine x, and for y, I'm going to substitute in sine x. So we have negative sine x minus sine x. That does not equal 0. It equals negative 2 sine x. And so y equal to sine x is not a solution to this differential equation. Let's go on and check our second function. Y is equal to 4e to the negative x. We're going to need to start off the same way and calculate the first derivative and the second derivative. Y prime, the derivative of 4e to the negative x, is negative 4e to the negative x. And y double prime, the derivative of negative 4e to the negative x, is positive 4e to the negative x. We're using the chain rule to take those derivatives. So now let's plug them into our differential equation and see if we get 0. Y double prime is 4e to the negative x. From that we will subtract the original function y, which is 4e to the negative x, and subtracting them does. So that confirms that the function y equal to 4e to the negative x is a solution to this differential equation. Finally, let's check our last function, y equals ce to the x. We're going to start and take the first derivative and the second derivative. In this function, c just represents a constant. So I'm just going to use constant multiple rule and the rule that the derivative of e to the x is e to the x to find that both y prime and y double prime are ce to the x. Now I'm going to plug them into our differential equation. Y double prime is ce to the x. From that we will subtract the original function, which is also ce to the x, and that does give us 0. So that tells us that the function y equal to ce to the x is a solution of this differential equation.